of having a workshop is we get input of stuff you like, you don't like, what works, what doesn't work, what makes sense. So, this is kind of a mutual learning operation, if you will, particularly in a subject matter that's highly dynamic, where nobody has the answers and there's all kinds of pitfalls and challenges. So I think you have to be very open-minded and very humble in this field. Otherwise, as we used to say in the military, you fall on your sword. So you have to just be constantly aware that you're dealing with subject matter that's confusing, that people have difficulty with, and we're making every effort to explain it, making every effort to make it visually understandable. In other words, to have the best plots and charts and explanations we can. We're up to about 350 pages right now, by the way, and it's only going to get worse. But we're trying very hard to include stuff, but make sure it's explained clearly. And that may differentiate it from some other classic books. So we'll give it a couple of more minutes. People are still signing in, so we'll get started here shortly. And we're actually going to introduce a new software program today. You probably said, oh no, just when I'm learning Orange. But we want to make you aware of another one that's highly valuable that we will incorporate in the book and we will refer to from time to time. So that's coming up in a few minutes. Just had another person that I admitted. So we'll wait again to probably about 5 after.
Good morning, Kelly.
Hi, good morning. Good morning.
And there's Darren Gates from the UK. Welcome to everybody. I know a few people are on quite a bit different time zones, so thank you for making the effort. For many of us, simply mid-morning US time, so it's pretty simple, but for others, it's a challenge, and I appreciate your motivation for sticking in there and signing on. So we still have a few people coming in. So we'll wait a few more minutes before we get started. We are being recorded now, just so you know. Can you all see the screen that says Chapter 2 summary?
Yes.
Good. Okay, because we're going to start with that in just a minute. We'll give it one more minute. If nobody new signs in, we'll get rolling here. Good morning, Darren.
Afternoon.
Oh, afternoon to you. Yes, and good luck in the World Cup, by the way.
Thank you. Yeah, just I'm watching the Morocco game out of the corner of my eye, just to see who we might face.
So yesterday was all about penalty kicks, huh?
Absolutely, yeah, fantastic games. But
I watched. In fact, we're dealing with the University of Amsterdam, and I hope to get a response from them yesterday, only to realize their attention was totally on the World Cup. They could care less about academics.
Yeah,
So
it's a big distraction at the moment for lots of ways.
for sure, for sure. Okay, I think we're going to go ahead and get started. Let me begin again by saying welcome and thank you for your time and dedication. As always, though, I want to give a shout out to anybody new. We have, I know, at least one. And Stephen, you want to go ahead and just introduce yourself, unmute yourself and say a few words?
Most definitely, most definitely. Thank you, and I'm very happy to be here. My name is Stefan Bronsberg. I am at Nova Southeastern University down in Fort Lauderdale here in Florida. I don't know how many folks are from Florida here. There's a few, I know that. I do know some of the other folks that are here. And I am the director of the master's program in health informatics. I also am involved in overseeing the undergraduate program in health informatics that we have here. And a wonderful colleague of mine, Dr. Rana, and I put that undergraduate program together. So it's up and running for just over a year now and is doing quite well. So we're happy about that. And let's see, my interest in data science, it stems from our program and our graduate program. We had some courses in data analytics, or analytics, if you will. And it was really heavily, the classes were heavily coding. And it became a distraction for our students to, think about the coding and understand the coding. And we're trying to get across to them data visualization, working with data, types of data, what is data, what data do I need, how much, do I need it all, and when I throw it into the software and it comes out on the other end and I see this wonderful, beautiful chart, what is it telling me? Do I understand it? Can I decipher it? Is it the right information? Does my gut tell me that it's right or wrong? Or we want to get our students thinking more about what is data, analyzing the data, and being comfortable with that. We're not creating so much the pure data scientists. That's not our mission. Our mission is to produce folks that are working in the trenches in clinical informatics, across the spectrum of healthcare, to be able to work with the data and contribute to the team, for positive steps moving forward. So that is my interest in it. And with the help of some wonderful folks, and one of them is here right now, Dave Petrishkoff, we took the courses that we had, the existing courses, we pared them down, we pulled out quite a bit of the coding part of that and incorporated software such as Orange and Tableau, et cetera, for our students to hopefully easily work with that software so they can concentrate the rest of their time on the data and working with that and what it's telling us and understand and analyze that data.
Okay, thanks, Stefan. I mean, we aren't putting a whole lot of emphasis on data here with this chapter 2, because we do think that data literacy is really important across the board for pretty much everybody in an organization that touches data. So that is an important thing. What we're going to go ahead and get started then. And what I wanted to start with here is showing you that we've added something called key principles. See the key, no pun intended there. But so at the beginning of the chapter, we'll outline the key principles. But as you scroll down, you will encounter, this is the very first one, about why this is important. So when you see a key principle, it's a flag. Know this is important, in other words. And I think most readers understand that and get something out of it. Okay, the next thing that we added that Dave's going to talk about, this was his contribution, and there have been many by him, is the 8-step data science process. And Dave, take it away with this diagram.
Sure. As you see here, we have, you could go on the internet and find a variety of, data science processes. Looking at all of those, we came up with our own that we feel that is pretty good and pretty solid, and tries to stay away when we possibly have, super technical words that are maybe complicated to understand. But what's more importantly than showing, okay, here's 8 steps is if you scroll down a little bit, Bob, you'll notice like in this example, this is explaining a little bit more of the details for step number 1. And we go into some pretty exhaustive explanations of what exactly are we doing there. Like in this step is saying, okay, asking the questions before you even get started. There's a lot of questions you should ask of your organization, of yourself, and of your data before you get started. And some of these steps, like step 2 and especially step 3, where we get into data wrangling and data prep, there's a tremendous amount of steps. And we're trying to, as much as an autopiloted checklist as you could think of. And when I say autopilot, it doesn't mean something's going to be done for you, but that if you look at, a long book and you go at each individual section, that you will find these steps, not only the steps, but the sub-steps and the task within them that are shown in the correct chronological order that you should be following. And then we're also working on a super master checklist that you could also download that'll include all of these things to make sure that you're going along the right path. Okay, Bob? And
okay, David, I think that's a good segue though into the idea that we are developing checklists that we'll make available. One's almost done, but we're just not quite ready to release it. You want to comment further about that?
yeah, we have we have individual checklists and we have sub checklist, and we're trying to figure out exactly how to split it and show you what that looks like. And then, like Bob said, when we're done with that, we'll publish that somewhere, and you could download that and kick the tires on that.
And then we thought that we probably would have more than one checklist. We got carried away with the idea that the data prep is an obvious no-brainer. I mean, it's very important that you go through a fairly methodical checklist, but modeling the same. So we're going to probably have then a checklist on modeling as well, which I think I would hope that you would find very valuable. The next thing that I want Dave to comment on is the importance of data experimentation. Last week, I harped on the fact that data is pivotal to data science, of course, but data quality, data quantity, and preparation is more important than what model you select. But the second thing that's so important is knowing how to experiment to find the right answer. Dave, take it away.
Yeah, it's very interesting in the world of data science that, you could look at any article and book that you want, and you will find guidelines, and sometimes these guidelines are all over the map. And it's very difficult at times to find somebody to say, all right, you must take your data and you must transform it this way. You must always normalize it and never standardize it, as an example. But what we want to promote, and you'll find this everywhere, and we find it in our own data experiments, is that depending on the data set you're looking at, one method might be better than the other. And that one method that works fantastic for one data set and knocks it out of the park, gives you a wonderful predictive model, might be just as terrible on a different data set. So again, what we want to teach you from the very beginning, and we mentioned it throughout the book, is the topic of experimentation. When in doubt, experiment. And we also want to make sure that nobody is intimidated by, oh my gosh, there's eight different types of data transformation. Well, how do I know which one I'm supposed to use? Well, here's the answer: experiment. You create a column for each different type of data imputation, data transformation, data balancing method, and then you experiment in the model with the different algorithms and see which model gives you the highest accuracy and the highest performance. So it's all about experimentation. And we do a fair amount of experiments throughout the book. And we also want to make sure we teach everybody how to be a master experimenter.
Well said. I mean, that has been one of the major contributions to this book, is David's experience with experimentation to come up with answers. What is the best way to approach this particular outlier? In other words, we hope that there would be more golden rules. There are a few, but otherwise you do have to experiment. The next thing that we're going to talk before we get into the actual chapter stuff is that we've added a new chapter on class imbalance. Why do we do that? Number one, because it's so common in medicine. In other words, so often when you have a data set, the thing that you're interested in, let's say biopsies that show cancer, is on the order of like 5% are cancer, 95% are benign. That throws a monkey wrench into the analysis, and it creates all kinds of new issues. And so this chapter is going to try to address that to the best of our ability and include what really amounts to be a fairly exhaustive list of all the things that you can do that you won't find in other books. You'll find 2 or 3 in one book, another 2 and 3 in another. So this is an attempt to combine all of those in one chapter, and it's fairly complete. I'm not ready to show it to you yet. We will get to it. Okay, the next thing is, let me see if I can get the menu out of the way. Just for those of you who are new, we do have our website, nocodedatascience.net, but there is a file share site. Hopefully you can see this. And then I opted to make each chapter have a folder. So for this, for instance, for chapter 2, if we are using a data set, this is where you'll find it and you can download it. So you just go to nocodedatascience.net and then use the file share tab, and that's where you'll find it. Okay, the next thing was a little bit about the end game here, that we do hope to launch at some point a course that people can take asynchronously on the internet and perhaps get certificates. And Dave has a lot more experience with certificates in the direction we might head. So Dave, I'm going to leave that one up to you.
Sure. Yeah, as we know in, for example, in comparison in the Lean Six Sigma world, that kind of lives and dies by different levels of certificates and different levels of expertise. And we kind of want to do the same thing. When I say same thing, we're not going to necessarily call it like a yellow, green, or black belt, but we will have some type of designation. And at the moment, we're thinking of leaving it at 3 levels of certification, so that if you say, all right, I want to go through this book, I want to go through this topic, and I just want to be somebody who's very familiar with the concepts, and I don't want to be an expert, but I want to be able to talk about them. I want to understand the vocabulary. So that'll be 1 level. And then, the next level will be somebody that could actually be, a good analytics contributor, and whatever we call that level in detail. And there'll be specific classes and, exercises and tests that those students go through that. And then for the highest level, for those people that want to be an expert and everything that we're talking about there, that and throughout this entire course and book, we'll have a different series for them that will allow them to go through a series of videos and practice exercises and, practicing the analysis with a lot of data sets, so that they could actually have something, a certificate that will be meaningful for them and will be meaningful for their career.
Okay, thank you very much. So the last thing before we get started is, again, to tell you about a second open source stats package that we're going to use from time to time, called JASP, J-A-S-P. And it, oddly enough, it stands for Jeffrey's Amazing Statistics Program. Sir Harold Jeffreys was a famous British statistician, and this program, though, doesn't come out of England. It comes out of the Netherlands, specifically the University of Amsterdam. So I'm going to give you just a few bullets about this program, and then Dave may show you a few test drive things. But we can't today go in much detail, but over time we will go into it. So number one, it's free, open source. They constantly update it, which I'm happy to say. One of the unique features is that the entire program is divided into the two schools of statisticians that are out there. The frequentists are the classic, the people that go over, mean, mode, standard deviations, and t-test and ANOVA and whatnot. The second school, though, is Bayesian. And so it does both, which is fairly unique. And let's see, the software connects to the Open Science Forum. If you're doing research, in other words, what you do, you can collaborate with that forum, and it's all wrapped up in one nice package. You also, if you want to convert some of the stats packages files like SAS transport files or SPSS files, it can do that for you, even without you having a copy of SPSS or SAS.
But Bob,
Yeah,
we're still seeing your 8-step data science process screen.
Yeah.
Is there another screen you wanted us to see, or if not, that's fine.
yes, yeah, no, thank you for, in other words, what I said was Dave is going to show you.
Oh,
a
great.
screen.
Okay.
Yes, Dave will show you screen in a second, but we're
Got
going
it,
to
okay.
make this short because we've got other stuff to cover. So it does very good for modeling, by the way, both supervised and unsupervised learning. Doesn't do any AI per se. But it does do some things that Orange does not do. It fills in a few voids. And also we're going to get on a Zoom call to find out what new educational stuff they're going to introduce in January. So I think you will find this another wonderful program like Orange, in other words, and we're going to try to figure out how to integrate those, if you will. Okay. So Dave, you want to pull up your screen and just give them a quick run through of JASP?
Yes. Bear with me. Okay, let me know when you see a screen that looks somewhat familiar to a piece of software.
We do see. it.
Yes.
Okay,
Yeah.
so now here's the beautiful part of JASP, and Bob explained some of that already, but it's incredible. And they use the word amazing. I use the word incredible. It's almost like it's not software, because I went through and I did 98% of everything you could do with this software, and I didn't even have to open up the user manual. That's how simple it is. So this is a simple, an example here. The only thing you really have to do in the beginning is say, okay, what kind of data do you want to analyze? You got your list of your data to the left, and you click it over here, move it to the right. And then that's all you're doing is checking or unchecking what type of analysis you would like the software to create for you. And then when you click all these things, that's shown on the right-hand side, what's called the analysis pane. And then when I maximize that area, it shows me all those stats, all those graphics automatically, without me having to do, anything more than one click. And I want to go back to the analysis pane. And the one click I do is I say, no, I don't want Pearson R. No, I don't want Spearman's row. And no, I don't want Kendall. Or yes, I do want to have display pairwise. That's all you have to do is say, I want this, and I don't want that. And it automatically pops up on the right. The only thing you have to enter in the very beginning is your data. And we'll talk about that another time, how that happens. And then here you enter, all right, what's a target variable and what's a contributing predictor variable, and that is it. So it is incredibly useful. You're just zooming around at the bottom, clicking around, and you see, anytime you see something that's empty, that's an opportunity to open it up. And the beauty is they've also added a whole bunch of Six Sigma analysis capabilities, which is marvelous. So I think I'll stop right there, but to call it software is one thing, but I just want you to understand and say, oh my gosh, what kind of learning curve is there involved here? There's almost no learning curve, because you're just saying, do this or don't do that. Check, uncheck.
Thanks. That's excellent. And let me just see if I can share back what I have. The other thing is, just so you know, the images are APA quality. That doesn't come in, that's not important most of the time, but for the better journals like Annals of Internal Medicine, New England Journal, they wanted any diagrams or plots to be APA quality. All right, I'm going to go ahead down and basically do 3 sections fairly quickly, fairly easily. The first one is log transform. Now, why in the world will we even discuss that? And that's because if you're using something like a t-test or a ANOVA, the assumption is that your data is normally distributed. But guess what? In medicine, it isn't very often normally distributed. For one reason is, think about it, most of the time with, say, a lab test, it doesn't begin below 0. It's not minus 20, and you go up to plus 20. That would give you a nice normally distributed curve. It starts perhaps at 0 and goes up to 100, let's just say. So it's skewed to the right, or a positive skew, if you will. And so, you know, theoretically, you'd want to transform that. And the way in orange would be, you would do a log 10 transform. But we want to throw out a red flag here. There are articles suggesting don't do that. You may not run across articles like that. So this, another thing that we're trying very much is to give you both sides and say, wait a minute, not so fast. You may want to experiment and see if it really, what happens when you do a log transform. I'm not going to show you a log transform. I'm going to show you one other thing that you can do. But there are other transformations we won't go into right now, such as power transformations. But just understand, there may be unique situations where you will want to have a more normal transformation, but we don't recommend the log 10 transformation at this time. There also could be instances where you would like to create a new feature. The classic one is, let's say you have height and weight, and you want to create a formula to a new column that will be BMI based on height and weight. That can be done in the feature constructor widget. Now, to do that, it requires those sort of some Python shortcuts, which we're not going to, at this time, we're going to be very specific. If we find an instance where the data set requires that, we're going to teach that. I'll show you one if it'll come up here. Let me see what happens when I put this back down. Yeah, so I'm going to show you just simply multiplying variables. What if, for instance, there's something called a double product, which means you're multiplying the heart rate by the blood pressure. To do that, you just put resting SPB, systolic blood pressure, and the asterisk is the multiplication times the max heart rate, 2 columns in the data set. And then what you see, if you open up a data table now, and let me get the menu out of the way so I can see it. As you go way over, let's see if I can do that. Now to get my picture out of the way. See, the last column says double product. So that was the new column that I created just by doing that in the feature constructor. So now this is multiplying the maximum heart rate by the blood pressure. So that, again, that may come in handy. We may eventually do it. It's hard to say, but we're not going to go into detail right now. So the third thing that I'm going to talk about, then turn it over to Dave, is what's called one-hot encoding. What you should realize is that there are widgets or operators or algorithms that don't want categorical data. They want it to be all numerical. An example of that is the diagram here, figure 2.26, where you see animal, dog, cat, sheep, and so forth. Computers would rather analyze zeros and ones, for instance. Also, there are times when, if you're not careful, you don't want the computer to recognize, say, dog is more important than animal. These are all on equal basis, let's say. So what it does, it creates a new column. If so, under dog, if it is a dog, that's a 1, and all the rest are zeros. So that's what one-hot encoding is. Don't ask me where they came up with that name. I'm not sure. So the new variables are called dummy variables or indicator variables. So that's what it looks like. And that actually, when you use linear regression, that widget, it automatically does that behind the scenes. You don't have to tell it, but there is a wrinkle there that we want to introduce. We want to tell you there's 2 problems with one-hot encoding. One is that what if you've got 10 categorical variables? You've got animals, you've got what else could be hair color, on and on and on. And now you're going to create all these new columns. Maybe you created 50 new columns. And that's like, uh-oh, because now the model is more complicated. You've added 50 columns. That's going to perhaps cause overfitting, which we'll get into in great details down the road. But that's one problem. The second one is something called the dummy trap, dummy variable trap, rather. And that is, you don't want two columns to say the same thing. And we'll try to explain that. When two columns are highly correlated with each other, they're guilty of multicollinearity. That's what it means. In other words, a good example of that is you've got a data set and it has income and it has education. And lo and behold, income and education are correlated at 0.9. Let's say you don't need both, you need just one, let's say. But there are other examples of that you have to be careful of. David gave the example that you don't want to have a column of cancer, yes or no, and next to it, benign, yes or no. You just need one column, cancer 0 and 1. If you have those two columns, they're completely correlated with each other, and that it may interfere with the model. If you want to know whether your independent variables are correlated, you would use a correlation widget, and we'll be going into that in great detail. So the independent variables are the predictors or features. They're supposed to be independent. Notice the word independent. Whereas a dependent variable, which is your outcome, you expect your predictors or independent variables to be related to it, or correlated to it. So we will be spending more time. In fact, the next section, we'll spend a lot of time on multicollinearity, but just understand you don't want your predictors to be strongly correlated with each other. That creates problems. And there is a way around it that you can use the continuize variable, and we'll explain that in a second. But what in essence it does, we'll try to demonstrate, is something called n-1. So instead of 4 of those columns, it becomes 3 because you don't need all 4. And we'll try to demonstrate that in a second here. So what David did, and I'm actually going to show you the workflow here, and I have a workflow myself. Let's see. Here's the workflow where you put the continuize widget in before, and you're doing this to demonstrate with data table, but I'm going to demonstrate it with linear regression, meaning you're given the model a different set of variables, but you can demonstrate what you've done always by using a data table. So going back up to the continuize variable, you've got really a couple of choices. One of them is one attribute per value, so that you would get a column for males, a column for females. But again, that's guilty of this dummy variable trap. This one is the most ideal. First value is base, is going to take the most common one alphabetically. It's going to exclude that one and have the others, and we'll demonstrate that. And the most frequent value as base is just what it says. The most frequent is the one that it excludes. David has a nice demonstration here, and let me just show you, and I'll have one in orange in a minute. Is so the first option 1 is each variable gets a separate column, and that's why I made it in red. In other words, this is a home health data set where you have 3 levels of impairment, A, B, and C, in other words. And so here you've got a column now A, B, and C, 0s and 1. The problem is it's guilty of the dummy variable trap, whereas the second one is actually deleted A and just uses B and C and accomplishes the same thing. And this one just uses the most frequent. Let me pull up an orange demonstration of that. So here we have a file, and when you open it up, what I did is to make it a regression. I said, I want my outcome to be the millimeters of ST depression because that's numerical. And so the continue-wise, if you choose, let's choose one attribute per value, what you're going to see, and let me get the menu out of the way, is each one gets a column. And that's what you don't want. You see a column for female, a column for male. That's not what you want. So if you select instead the default, which is first value is base, and you pull it up, then for gender, it just says male. 1 means, yeah, it's a male. 0 means it's a female. And you don't have 4 chest pains, you have 3. So you don't have any 2 columns that are super correlated with each other. I hope that's clear. You've got the book to read about that. Let me see, there's something in the chat before I turn it over to Dave. Yeah, so somebody commented that similar to orange, it's just every bit as easy to understand as orange. Yeah. And overfitting basically means that the model overtrains in a sense on all the stuff you have in your data, the signal, the noise, you name it. But then when you try to test it on test data, it is much worse. So see the quick question, what are some reasons why you would want to generate polynomial features? Wouldn't that generate correlated columns? We'll get into, under regression, I think we'll get into polynomials. We won't do it today to answer your question. David, for time reasons, I think we'll need to move on to your session.
Okay, let me grab the screen share. Bear with me. And get back to the next section. Hope you could all see this now. Group calculation options.
Yes.
Yep,
Okay.
you may want to go to 125 magnification though, just to be on the safe side.
Yeah. Let me back it down a little bit. So that's easier to see. So what are group calculation options? So we have in orange, we have, anytime we have a collection of these widgets, as Bob has been showing you, and we've been showing you before, we have the opportunity to say, all right, we want these are calculation options, calculation opportunities. That's what these widgets are. And you see very often in previous, what we call workflows, that we always kind of add a data table to the end of it. And why do we do that? Because it automatically will calculate and show, kind of like in a spreadsheet format, everything that we've had before. So in this section here, if we have a variety of groups and we want to know, hey, we want to know some statistics based on the specific groups that are shown in the data set. Well, this will help us to get there, and this group by widget will help us to create those kind of stats that we want to have. And if you scroll down to the bottom, if you click on that group by widget, you have these options. The first thing it's going to show you is, all right, here's all of your columns that you have. And you could click off to the right, and it'll then ask you, okay, what do you want to have for, in this case, like glucose? Do you want to have the mean, the median? Do you want to have the standard deviation, or do you want to have something else? And in this case, as just an example, it's shown the mean, as was shown for the age and a few other things. And then it'll break it out. Now, this is by group code, so it's going to break it out for the groups of diabetes 0, 1. And what does that stand for? Obviously, 0 is no diabetes and 1 is diabetes. And then if you collect and if you connect that widget to the data table widget, you will then get this nice little table whereby you have, in this case, this very simple example of the means shown for glucose, age, systolic blood pressure, waist circumference. And the groups that it did it for was 0, no diabetes, and 1 for diabetes. So this is a very handy exploration, data exploration type of widget to give you some statistics so that you yourself can then explore and say, hey, is the mean higher for diabetes patients? Well, you obviously in glucose, you can see, yeah, it's off the chart. It's like 100 more. It's more than double. And age, well, there's a slight increase of the average age for diabetes patients. And you look at systolic blood pressure, there's just a slight increase, not this huge increase we saw like in the glucose level. And then we see here on the waist circumference, we have just, again, another slight increase. So this is almost like a pivot table summary of some of the main stats that you determine that might be interesting for your pre-analysis, pre-exploration of this data set. So that's what this group by widget can offer you. And again, why is it grouping by and what does it give you? It's breaking out the data by the groups or by other types of feature statistics widgets. It can break it out by groups, but it's normally not intended to do that.
Dave, if I can make a comment, that's really nice for exploration because you could do multiple columns. If you needed to know whether it's statistically significant, then you could use the box plot to compare them because that'll give you a t-test result. So you can, again, could use both of those in your exploration.
Exactly. Yeah, and you get the p-value there for the box plot to tell you if there's any difference between the two groups. So you could take this all these groups here and say, okay, they're close to each other, but are they statistically significant? And just like Bob said, you could bring it into the box plot and then see if the p-value is below 0.05, which means that you do have statistical significance. So the next topic is feature splitting. Now, feature splitting, and again, we have to remember what chapter we are in. We are in, because it's a long chapter, so we talk about it for several sessions. We are in the data wrangling, the data pre-analysis of the data, trying to sort out the data, organize the data, clean it up. So here, when we're trying to split our data, there's going to be a variety of tasks that we want to do up front before we even do our analysis. And some of these tasks can be very easily be done in Excel because very often your data is going to come in from Excel. It might come in from a CSV file. It could come in from a different format. But for example, in data splitting, if you want to break out the difference, if you want to say, all right, I have the dates. What's the day of the week? Well, that's, you could split that feature into a different column, and that could easily be done in Excel before you even get into Orange. Or if you're trying to break out different types of date codes or other things that are easy to do, we could easily do that in Excel before we get into the Orange platform. Now, what's important is what you always want to understand in the beginning is what features do I want to split? So let's say you get some data. The first thing you want to do when you get some data is say, all right, what can I do with this data to get more information out of it than what is actually there? Like I just mentioned, dates. What can I get out of a date? Well, I could get day of the week, And what do I have from time? Well, I could break it out by hour of the day as opposed to 8:25 a.m. I might be more interested in splitting the data out into rounder buckets of hours within that day. So there's a variety of different things you want to ask yourself. So it's not just doing the mechanics of feature splitting. It's you looking at the data and meditating over it and saying, what can I extract out of this data more than what it's telling me already? And that's where the whole strategy of feature splitting comes in. There's a lot of clever ways like Bob showed you before, multiplying one feature times another to give you another important feature you could experiment with your analysis. And there's other things that you want to do is as far as splitting the data. So the next section is feature scaling. Now, what in the world is feature scaling? Well, let's say if I have, I have one column that says age. Well, okay, the ages might be, depending on what data set I'm looking at, it might be, people that are the age groups of 20 all the way up to 75. And then I move on to the next column, and that might have some type of lab test. And that lab test, the data might only go from 0 to 20. And then I move on to another section, and the scale might be very different, right? And then, like Bob mentioned before, the topic of let's say if we had a column of income, and let's say we included the CEOs, right? So we can imagine we'd have scales of anywhere from the bulk of the data might be from 30,000 a year to 100,000 a year in the corporation, and then you get into the executives, and it becomes you get some much larger numbers. So what is feature scaling, and why do we even care about it? Well, as you might imagine, a lot of these different scales for whatever we're looking at could create some havoc with some of these algorithms. It might say, I don't like that this one feature you have, this one variable scales from 5 to 12, and then the other one scales from 15 to 200,000, and so on and so forth. So what we have here is a continuous widget within Orange, and you can see here we have 6 different scaling options that we could do. First of all, we could leave it like it is, and then the second one is described a little bit further down also. You could standardize the data, which means, all right, my average is going to be 0, and my standard deviation is going to be 1. And then another way to scale the data, say, hey, I'm going to center everything around 0. I'm just going to force everything that data and just make the average of 0, and then there'll be some pluses and minuses around that. That's one way to rescale the data. And then we could rescale it so that they all have the same, number 4 is they all have the same level of standard deviation. And then I could get really creative and say, you know what, number 5, I want to force all the data into a format where that the lowest number is always -1. The highest one is always a +1. Okay, that's a different type of scaling. And then we have option 6. We're going to normalize it to an interval where that the lowest value is always 0. I don't care if the lowest value in the normal data is 25. Let's say if the data originally starts at scales from 25 to 100. Well, this option number 6 is going to force it the lowest value to a 0 and the highest to a 1. It's going to do that for all of the columns. Now you might say to yourself, oh my gosh, how in the world am I supposed to know which one of these my algorithm is going to appreciate the most? Which one of these methods is going to provide the best outcomes and best predictions for my model? Well, the way you do that is kind of like our golden word for the today is when in doubt, experiments. So what you want to do is you want to, with one click here in Orange, in the continuize section, you could change how that data is formatted, how it is scaled. You can then automatically have a workflow that feeds that data into linear regression, neural networks, and whatever, and it goes later, and we'll explain later, it goes into a test and score widget, which tells you how good the performance was of that outcome. That's all you have to do is click these different options and find out which one of those actually performs the best in your predictive modeling, and also which one has the lowest error and the highest level of accuracy. And you might say, hey, wait a minute, is that like cheating? Am I like cheating? Well, keep in mind, this is all just numbers, and we're trying to take these numbers and use it for predictions. And if we're doing anything crazy, the prediction will fall flat on its face, and we'll say, hey, you did something here with the data, and we can't do anything with it. But if a lot of these types of data rescaling will make it easier for the algorithm and faster for it to work and come up with a better solution for us. So that's why we like to experiment with these different methods. So again,
Dave?
yes.
Yeah, sorry to interrupt. There was a question because option 2 and 3 look somewhat similar. Comments on how they're different?
Yes, the difference between 2 and 3, on number 2, we're constrained that we want to make sure that we're always breaking it out into different levels of standard deviations. Whereby option level 3, it doesn't care what the standard deviation is. It's just going to turn everything into a 0 and a 1. And I have some graphics below that will explain that a little bit. And let me scroll down to that right now. So here we see, if I click option number 1, here I had an example of 4 different data sets in the diabetes data set. Here I got age, glucose, systolic blood pressure, and waist. You can see they're on very different scales, and that might trip up an algorithm. Now let's look at, what does that data look like if I use option number 2, where I'm standardizing the data? Well, you can see things get a little bit closer to each other. And I'm not dealing with wild ranges, because you can see the whiskers, which are these lines up on the positive and the negative side of the outputs of this box, which contains 50% of the data, and this white line is the median, by the way. You can see that the scales are pretty much forced to be into the kind of like the same general category, which might make the predictions a little bit easier for the algorithm. And then you get to the next option, which is number 3, numerical scaling. And you can see here that option 3 is going to look like this. Option 4 looks a little bit differently. Option 5 and 6, you can see the scaling is looking a little bit differently, but it's most important to understand that we can see that the min and the max are forced to be very close to each other. And that's the purpose of, for example, normalizing the data, forcing it into a -1 to a +1, or forcing it at the bottom example here is forcing it, the lowest value is always going to be 0 and the highest is always going to be a 1. So again, you could read books and read blogs and read articles and say, oh yeah, this of all these options, this is the best. Well, guess what? As mentioned before, that may be true for a specific data set, but it may not be true at all for a different data set. So you have to experiment yourself. So again, if you're going to try to come up with the best predictive modeling, you don't need to be an expert on each one of these methods and understand incredibly in excruciating detail everything it might be doing, but you need to be a very thorough and disciplined experimenter, so that at the end of the day, you might come back and say, hey, you know what? This option number 6, where everything was forced into the max a +1 and the lowest range was a 0, that worked out the best for my algorithm, made it the happiest, gave me the best predictions, and you're good to go. And you might say, well, again, you might say to yourself, wait a minute, is that somehow cheating? Well, not really. And why is it not cheating? Well, because keep in mind that all these theories that we're using, we are actually then coming up with these theories, passing it off to various algorithms and say, hey, okay, algorithm, you're going to test this on data you have not seen. So if you were cheating, you'd be busted pretty quick, because the cheating would not go far in trying to predict a data set that you have never seen or the algorithm has never seen. The algorithm will only produce great predictions that it has not seen if there's really some underlying logic to the data and how it has been formatted or how it has been transposed. So that is that section, what it looks like. And I wanted to show you, pull up an orange widget here. And can everybody see my screen now where I'm showing the orange widgets?
Yes.
And we see here I'm clicking on it right now, the continuize. So here I got my data set, I'm coming in. And what kind of data set do I have here? Well, here I have, what do we have? This is the diabetes data set. And if I look at my feature statistics, I could, with that widget, I could go here and I could see min max. I could see I have a bunch of issues here where that scaling is an issue, right? And so we could see without the data being transformed, and the different color codes are for the different genders, by the way. And I could see that I have different min max ranges that could again create havoc for some of the data sets. And so again, if I go on this continuize widget and I check option number 2, I want to standardize. And if I want to immediately know what that data looks like, I could then connect the feature statistics widget to it, and it'll pop up and show me what that looks like. And unfortunately, that is now off my screen because I did originally have some additional screens that were attached to it. So that's not cooperating at the moment. But what that would show you then, you could double check the range of that data under the feature statistics and see whether that helped or not. You could also go directly into the distribution widget right below that and say, oh, what did it do? Age. Okay, oh, age ranges from -2 to +2. How's that possible? Well, you go back over here and say, what was checked? Oh, that's because I standardized the data where that the average is 0 with the standard deviation of 1. And let's say if I say, all right, I'm going to normalize the data, from 0 to 1. That's the total range. And I go back here in the distribution and I look at age, you can see that it forced it into a 0 to 1. And if I want to look at under body mass index, what did it do? It did the same thing. Now it has its own shape, but it forced everything into a 0, the minimum value, and a 1, the positive value. So we could go through each of the values here, each of the features that you have, and have a look how that specific transformation of that data, what it looked like and what the rescaling actually looked like. And you could then click any one of these options that you have here to say, well, what does it look like for option number 5? Then you go back here into the histogram and you could exactly see, all right, that's what it looks like if it's rescaled, the low value -1, the high value +1. So that is the topic of feature scaling and feature rescaling. And again, experimentation will tell you what is the best option for you to look at. So what I'd like to do now, we're right there at the point where that we wanted to end today. I wanted to open it up for any types of questions that anybody might have that we could talk about.
Let me see what's in the chat here. Oh, Morocco won. Wow. There is an outlier, Darren, there is an outlier widget. We've covered it. We're going to cover it in more detail. In fact, let me, if it's all right, let me tell you what we're going to be doing next. And that is, we're going to be going over several very important aspects. If you look at the outline on the left, what we're going to cover before we get into orange widgets and a data exercise, both the importance of the curse of dimensionality, again, the curse of multicollinearity, the curse of data leakage, which is grossly underestimated, and the curse of class imbalance. You all should be concerned because, in other words, we've already hinted that there are lots of problems and hurdles and challenges with data science. These are some of the major ones that you have to contend with and are ignored all too often in a published article or a data science experiment. So they're incredibly important. Comments by anybody? I mean, I have a couple more comments, but I want to make sure I hear from you all who are here today. I'll show you one, and that is, notice the cover has changed because we're not going to use solely orange. We're going to use a blue color, therefore, on the cover. And also the subtitle has changed, that we added AI, and also the fact we're using open source software. So it's not 100% dependent on orange. I wanted to make that point. The other thing is, I saw on David's screen that there's a new version of Orange. Apparently, I didn't know that. You all should check it out. One of the problems with Orange, a criticism, in my opinion, is on their webpage, they should be telling you what's in every update. Otherwise, you have to experiment and find out on your own. And also, the next class will be January the 14th, unless you all have anybody know of an issue with that. But that'll be the Saturday. And let me go up to the add-ons, because if there's a new version, it should say it. Yep, and there it is. If you all can see that. So if you go to your add-ons, you'll see that there's a new 3.34. I'll have to look at it because this just came up today and see what it involves to see if they've added widgets. By the way, we've contracted with Orange to add some features. We're going to pay for that, but they continue on their own to add features. And so as they add them, we'll make sure we share that information and put it in the textbook. Are there questions, though? Otherwise, this will be recorded. It'll be on our YouTube channel. I'll send out a notice to everybody. And we'll, again, plan on the 14th unless I hear from somebody otherwise.
Hey, Bob, there was one question from Darren I wanted to, he was saying, are these all the same data sets, but they look different? The answer is, yeah, they're all the same data set, just transformed into different scaling.
Yeah, the other thing that I know will cause confusion, and I apologize for it, is that we continue to tweak everything. That's why I'm not sending you a new book or even a new chapter at this point, because we're going back and adding new things. We'll probably add some more images from JAST to chat all the chapters. There's a lot of work that still needs to be done. So we will send out completed sections of a chapter, but not the entire chapter, because again, it's still a work in progress, which I hope you all will be patient with, because I think the changes we made are very valuable, to be honest. And you know, we are trying very hard to make this complete but understandable. Other comments? I mean, if there are no other comments, we can close this session and plan to have the next one on January the 14th. I'll send out the Zoom and all the other stuff ahead of time. If not, I hope you enjoy the World Cup, the next match. And again, try to understand the importance of data in this chapter, which is lengthy and tedious, I realize, but still, nevertheless, more important in many ways than selecting algorithms and the cool stuff of pushing the run button. So, you know, again, thanks for your participation, and we'll see you in a month. Enjoy the rest of your weekend.
Thank you.
Take care.
Take care, everybody.
Okay, bye-bye now.
Take care. Thank you.
Okay.